This is chapter 6, page 14, and we're going to be graphing y equals secant theta. To help us graph y equals secant theta, I'm going to first graph y equals cosine of theta. And then secant's the reciprocal. So I'm not going to worry about every value here. The cosine of 0, ignore this where it says tan 0. Cosine, I'm going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. So this would be the normal cosine graph. So what I'm going to do is this. In red, I'm going to graph y equals secant theta, which is the reciprocal. So the reciprocal of 1 is 1. So again, secant's in red. The reciprocal of 0 is undefined. I'm going to put a vertical asymptote. The reciprocal of negative 1 is negative 1. The reciprocal of 0 is undefined. And the reciprocal of 1 is 1. So the graph is going to go away from the cosine graph towards the asymptotes. So it will look like this, because anything between 0 and 1, the reciprocal is going to be really large. So it's going to look like this, and like this. This is the graph of secant in one period. Domain would be all reals except pi n over 2, where n is an odd integer. And then the range here would be y is greater than or equal to 1 or less than or equal to negative 1. There is no maximum and minimum because it keeps on going up forever. I'll say non-applicable, and it keeps on going down forever. Y-intercept here is 1. X-intercept for the secant graph is none. I don't have to worry, or the asymptotes are at x equals pi n over 2, where n is an odd integer. And then the period here would be 2 pi. That's the basic period for a secant graph. Example 1, find the values of theta for which the equation is true. I'm going to make use of the unit circle and the reciprocal trig functions. So if it says we want to know where the cosecant is 1, the reciprocal of cosecant is sine. I want to know where the sine is 1. So if I look at my unit circle, the sine is 1 at pi over 2. So it's really pi over 2 plus 2 pi n, where n is an integer. B, it says where's the secant negative 1? It's wherever the cosine is negative 1. And the cosine's negative 1 at pi. And there's infinitely many answers, so I can write plus 2 pi n, where n is an integer. C says where's the tangent 1? Well, the tangent's 1 at pi over 4 and 5 pi over 4. So I'm going to just do it this way. I can put each of these plus 2 pi n, where n's an integer. And that will account for all of these. Example 2 on the bottom of page 14. Find each value by referring to the graph. I'm going to just do these simply by finding angles coterminal. Cotan is 7 pi over 2. If I subtract 2 pi, that's 7 pi over 2 minus 4 pi over 2, which is 3 pi over 2. So if I look on the unit circle, it says the tangent's undefined at 3 pi over 2. So the reciprocal of something undefined would be 0. That would be the cotan. Tan of negative 8 pi. What I could do again is find an angle coterminal. I could just keep on adding 2 pi. And then I get to 0. And then the tangent of 0 is just 0. And then see if I keep on adding 2 pi. I get cosecant of negative pi over 2. I could add 2 pi again, which is cosecant of 3 pi over 2. And that's the reciprocal of sine of 3 pi over 2. If the sine is negative 1, cosecant is negative 1 also. So these are the examples in the graph of the secant of theta from page 14 from chapter 6.